be doing the problem find if path exists in a graph. And for this problem, what it states is that given a bidirectional graph and a source and a destination, can we reach to a destination from a source? So what does a bidirectional graph means is that if the graph has got the node 0, 1 and 2, and in that case 0 can reach to 1, and similarly from 1 we can reach to 0. So that is the bidirectional aspect of the graph. And we have the edges. So what the edges comprise is the node that it connects to. So this edge connects to 0 and 1, and then we have got another edge that connects from 1 to 2 and 2 to 0. So given these edges, can we reach a destination of 2 from source of 0? So obviously we can reach, because from 0 we reach to 1 or 2, or we can directly go to 2. And so our output would be 2. Similarly, for this example, given these particular edges and source of 0, can we reach to destination 5? We cannot, right? Because if we are here, there is no way we can reach to 5, because there is no connection between 1 3 or 1 4 or 2 3 2 4. And so yeah, let's jump into the problem. I have designed this particular graph, so we don't have to wait to design it. And what I have done is that we have a node 4, and 4 is connected to all these nodes 7, 8, 2, 6, 9, 0, etc. And there is one more node 36 that is not at all connected. And we are supposed to reach to a destination 9. This is our destination, and we are going to start from 5. And how are we going to find that out? What we can do is that we can first find all those connected nodes to a particular node. So for 1, what it is connected to is 7 and 4. Similarly for 7, if I have missed that out, so for 7 it is connected to uh, 1 and 4, and for 8 is connected to 4, 2 is 4, 6 is 4, so on and so forth. 0 is connected to both 4 and 9. And the way of doing it is that we can start off with our source node, that is 5. Let's start off with 5, and once we are at 5, we are going to stack up all the possibilities that can hold 9. So 9 can either be in the connected, directly inside the connection, or inside the connection of the connection. So for example, in this case 9 is inside the connection of 0 over here, right? So what we are going to do is that once we start off with a particular node, we are going to stack up the connections that it has. In this case 5 has got a connection of 4, and now since we haven't found 9 in from 5 to 4, we are now going to move on to 4 and similarly stack up all the connections that 4 can hold, right? So 1, 7, 8, 2, 6, 0, 3, 5, and again we haven't found 9. So what we are going to do is that from 5, again we are going to stack up the connections for 5 and check if there is a 9 in there. And 5 has got 4. Now 4 we already have checked for 4, right? That is how we have arrived in here. And the other part is that we are not going to check for 5, because we already started off with 5. We are going to check for 1 to 3. So one important aspect is that every time we are going to stack up a particular connections for a source, we are going to remove that source and say this source is visited. so we don't end up recursively doing the same thing over and over again for this particular source. Now we have all these sources. For 5 we have got 4, and now once we start stacking up the connections that 4 can have, we remove it and put it to visited. So now we are going to check for 17826 0 3. Now coming to 5, 5 was already visited, so we are not going to put 5 over here. Now let's check what are the connections 3 can have. 3 can have 4, but 4 is already visited. We are not going to do that. We are going to remove 3 and we are going to say 5, 4 and 3. These are all are visited. We have already checked these nodes, right? Now we go to 0 and we remove 0, saying we are already at 0, and see that 9 is already present in 0, and what we are going to do is return true. So what are the important aspects we found is that we need to identify the nodes that we have already visited, and we are going to identify the nodes that we need to visit. There are two aspects. So one is what are the nodes that we need to visit, need, and what are the nodes that we have already visited. So once we have this thing, this queue, we can now start defining our code. Let's jump into the coding section. So we are going to create uh, a list, right, or a hash map from these edges. So what we are going to do is that given a hash map or a graph, whatever, we can just what we can do is hash map edges of I. So for, let's say, for 4 edges of I, we have to include append all the other edges, right? So you can even say it like this, sorry. There are two possibilities. One is the edge 0 and the other is edge 1. So inside edge 0 we are going to say whatever our previously edge 0 has, or we are going to define an empty and we are going to put edge 1. Similarly, for edge 1 we are going to get edge 1 and edge 0, right? So these are the two connections that we have, and like I'm just creating a hash map where uh, for this edge 0 and 1, 0 is now going to hold 1, 0 is now going to hold 1, and 1 is now going to hold 0, right? Now we have to like create our stacking system, right? So how do we create the stacking system? The stacking system is always like there is a loop from the source, whatever source that we have, and we are going to stack that up. So what we can do is that we can create a queue of visited, and we can create a queue of to visit, right? And just fill up the to visit with all the possibilities that the values or the nodes we can have. So let's say these are the nodes, and so what we are doing is this part. If we are starting at 5, we are going to fill the to visit to 4, right? Now once we have filled up the 4, then we are going to see the source of 4, and then we are going to fill it up with the rest. So we are getting all the nodes from the source, and we are going to fill up to visit with all the nodes, right? So how long this thing is going to continue is while we have got visit, right? While there are values to visit, we are going to keep doing it. So to visit should initially start off with the source. Now once we have started off with the source, we are going to like pop from the source. So to, and that will be our source, and what we can do is that we have to add that source to visited, and we check for all the nodes we have to visit from that source, right? Now there is one more thing, that is, if we have this particular source as visited, then we are not going to append. So what we have to check is, if node in, or if node in visited, if node is not in visited, then we are going to append, like I said, 5. We are not going to append 5 because we are already checked 5. So from 5 we came to 4. So only we are going to stack it up once the node is not visited, and we are going to stack up the nodes. And yes, that is okay. And what we are going to do is that if node equals to destination, then we are going to return true, or else we are going to return false. So we start off with the source, and we take all the nodes for that source into the to visit, and then we pop the to visit, and then we keep doing that till we reach the destination. And yes, so that is all. And there could be one more thing, that what if the edges that is supplied to us is null, there are none in the edges. So in that case, if the source is 0 and there is nothing in that edge, what we can do is that we can either get the source or this. So what we are doing is, instead of saying get the source, I mean we are creating a option for the hash map to have a null array, and in that case we can have a 0. So let's run the code, and there is an error. Okay, so hopefully there are no more bugs. Let's submit. And there you have it. Thanks a lot.